Okay. Today's a homework day, and we're gonna do a little bit of 3.4 because, well, you are gonna do it. You generally don't have a lot of questions here. And I would like you guys to talk through and reason through the answers that people have on the homework questions. I want to talk. So any questions on stuff? Like, can anyone reason through this one? Why the answer is what it is?
So the graph outlines something like this, and they don't have, I think it started with a negative value, which is like the slope or like that little part, like left to the horizontal, where the horizontal tangent is. And then I think it has a zero, for, y equals to negative, L is like, it has a zero at y, which is where the horizontal tangent is, and then it goes to positive values.
Okay. So horizontal tangent, like this is the derivative, and gave some reasoning. Didn't quite catch all of it. What are more reasons? And so some people know the answer, just because they can do the derivative. What are things that I can throw out that are definitely not the answer?
X squared and sin x.
X squared and sin x, why?
X squared doesn't have a negative value on sin x, it's just negative, positive,
There's
negative.
nothing over there. Okay, what about 3x minus 1 for the same reason? Changed? Cool. So then down to these. So the square root of x looks like this. Log of x looks like that.
It doesn't have the,
Oh,
okay.
yeah, so let's see. So that's the answer. Oh, I'm going backwards. If that's the function, what's the derivative? So you were saying, again, that there is a 0 and it starts off negative. Yeah, yes, no? Can anyone try drawing the first derivative on this? There are shades of correct answers. So what are cues that he should look at? To graph the derivative, what are some stuff to look for? I'll draw it on the same axis. So where are the help out, guys? What are things we should look for? Where there's zero slope. So where is there zero slope? Wait. Where does where does the function given have a horizontal tangent? Okay, so the derivative is the slope there. What is the slope there?
0.
So graph 0. And graph the other 0 for the derivative. Now the slope between those two zeros, is it positive or negative?
Negative.
Okay, so we need to draw something under the x-axis that connects those two dots, and it needs to be smooth.
Like,
Uh-huh. And then, is the slope positive there on out, on each side? So make a so the y values of the derivative will be positive after those dots. Yep. The original function, what does the original function look like?
Sine.
It looks like cubic. Doing the power rule of this cubic. George, what is the power rule on this? So it's gonna be some kind of parabola. It could be shifted up, shifted down, there might be some constant. Maybe this was plus 2x squared, and that ends up being a positive 4, or the way it's drawn, looks like more like negative. But kinda starting to see a little. Were you guys okay with matching these? So which derivative goes with the parabola?
B.
Straight line goes with that? How'd you see that?
Cause the slope like starts like really, like it's going down and then it goes up.
Super negative, 0, super positive, or gee, it's a parabola, the derivative of something squared is gonna be something linear. It's a positive parabola, so it's gonna be a straight positive line. Zach, what's this one? A, why?
It's like, it's just part of the entire time, like it starts on negative, it goes.
Positive slope the whole time except right here, one tiny little 0. Michael, what's the wiggle, wiggle, wiggle? The other wiggle, wiggle, wiggle. All right. You guys have a question on that? Sorry, it's poorly copied, but. What did you guys get for 28? Question? Or are you guys saying this was not on the homework? This is probably last night's, because last night's had to do with differentiability. Okay. First of all, for it to be differentiable, what else has to be true? It has to be continuous. So first thing, check continuity. One from the left is 1, which also equals f of 1. One from the right is 3x plus k. So it'd be continuous. Looks like K has to be -2. Which makes this a stupid question because what's the derivative of this piecewise function? What's the top part of the derivative? 3x squared. And I'm gonna just say for x less than 1, I'm not gonna put the equal sign on there yet. And the derivative of the bottom part? Just 3. For it to be differentiable, I need the slope from the left of 1 to equal the slope from the right of 1. So it does end up that 3 equals 3. I can see the AP exam saying, find, if possible, a value of K that makes this differentiable. And it might not be possible. They might make it so that it is continuous, but that it makes a corner. So that this one you didn't need to do the derivative to smooth things together. Now I know. You didn't do this because last night's homework was on delta math. Okay. So, the delta math, did you guys have issues with those? There were systems of equations, and that is traditionally a weakness that I've seen. So you needed to find, where is it, like, make it continuous, you'll get something in terms of A and B, doing the derivative, and getting another equation from that, and then solving this. You guys are okay with those? Okay, because it gave you step-by-step solutions through them. Anything from 3.3 that was still part of the homework? I've lost track of what's where. You guys see this problem?
The counselor said that, I asked her that, she said, did you come here because you know who doesn't walk into their class? And she said she'll do the schedule. She was like, next year.
how do we find a relationship between A and B?
Uh, to make sure it's continuous, set like the system of equations to equal to each other.
Okay, so in the system of equations, we need to make sure it's continuous. So, yeah, exactly that. We need the left and the right to be equal to each other. And we need that filled in. So 3 minus 1, and that's what they meant by establish the relationship between A and B. Well, A plus B equals 2. Sadie, how do I need to find another equation with 2 unknowns, I need another equation.
Or you find the derivatives.
Okay. So what's the derivative of my piecewise?
It's negative the top one, and then 2x plus
Okay. For it to be differentiable, the slope from the left has to equal the slope from the right. How do I solve that system? Roman, what do I do? Well, how do I add these together? Okay, so you're saying substitute?
Yeah.
Okay. Just to be obstinate, I'm gonna show a different method. Can I just subtract them? So I'm gonna change the signs of this one and add down 2 plus 1, A minus 2A, B minus B goes away, A is negative 3. And if A is negative 3, what is B? B is 5. So there's 2 ways to solve systems, 2 main ways that we teach you. One is substitution, which works fine. But a lot of the numbers you're gonna see from here, if you need to solve a system, substitution's gonna be ugly. It's gonna have fractions and they're not nice ones. So, it's called linear combinations. Do you guys know how to do those anymore? Like, what would you do if you needed to find that solution? Michael?
Multiply this off by 2 and subtract 1.
Okay. So, I don't do the subtract well. I would just multiply by negative 2 and then add down. Whatever. I don't like subtracting. I can add negatives. I don't like subtracting. But yeah, so why did he pick the negative 2? Because when we multiplied out, the x's would drop out. Did you guys have questions on product rule, power rule, 23 by any chance? And if you don't have questions about 23, I do. Evan, you were in the midst of showing this work when the bell rang the other day. Can you do A? And can someone else volunteer to do B, showing the work? You can both write on the board at the same time, it's really exciting. There's 10 little fingers can be on there at once. Amelia? Cool. Amelia, show the,
okay.
it doesn't erase, so you just, yep. So show the pattern of quotient rule, bottom
Okay,
times the
yeah.
derivative of the top. So the first one, the derivative pattern for the product. First times the derivative of the second, plus second times the derivative of the first, and then we needed to take the values. So 5 times 2 plus -3 times -1, and we get 13. You guys okay with that one? So I want to erase and show some stuff. For these, I really, really, really recommend that you write out the alphabet soup first. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, so that if you mixed up any of the numbers, which I usually do, I can see partial credit to stuff, like, oh, you just misread, rather than, I can't tell if you know what's going on or not. So let's make sure we've got these right. Bottom, yep, times the derivative of the top, yep, minus, it's hard to erase on this board, so it's extra dark. Top times the derivative of the bottom over the bottom squared. And we get 3 minus 10 over 1, -7. You guys okay with following this kind of pattern? And this one, Cameron, how do I do this?
I kinda did it differently.
Okay,
So,
what's
like,
different?
I just basically made the u and the v like into like equations, so like -3x plus 5 and,
Okay.
2x minus 1, and then
All right, don't do that, don't create a function that has this derivative in that point, because that's, first of all, too much work and too much time, and can introduce questions and problems. 7 times the derivative of v minus 2 times the derivative of u. Derivative of v is 2. Derivative of u is -3. Much faster. Don't create equations, because it might not be true. Any issues with quotient rules? And strategies. 15? Anybody do 15? $15 would stink as a quotient rule, because it's a big, huge mess. What is this multiplied out? Let's see. X cubed plus x squared plus x minus x squared minus x minus 1. So that numerator multiplies out to be x cubed minus 1 over cubed. So,
Ms. Wisco?
Yep.
Can you just look at it and see that that's x cubed minus 1?
I can,
So,
okay. The number of you that can, first of all, that remember the factoring pattern for the cubed, maybe half of you. And to see it in reverse, less than half of that, but if you get it, sure. But now, doing the derivative, I still wouldn't do quotient rule. I would do a strategy that I call divide and conquer. I still haven't done the math yet. I've only done algebra, I haven't done the calculus. Now, if this is my function, the derivative of 1 goes away, the derivative of this one, multiply the power and lower the power. So multiplying by -3, the negative is still there, so negative became +3, lower the power. We will do the divide and conquer a lot, yeah.
So if I did it, not dividing, conquering.
The longer way. You get, if you get the right answer, that's fine.
Simplified,
Okay,
because there's a lot of.
okay, if it's not simplified, then it's not done. So this is to say, there are more than, there are a number of ways you can go about solving this. There are some that are sleek and clean and fast. And if you do it the long way on a test or a quiz, you're not gonna have time. This one also, divide and conquer. I don't think I assigned that one, but doing a little bit of the algebra first. Still did not do the derivative. So don't fall into that trap. People have said, wow, I did all these steps on the problem, I must be done by now. But you didn't answer the question. See, what's the derivative of this function now like that?
0 plus, 5/2. Is that?
5 over, multiply by the
X
power.
to the 2, x to the second.
Okay. But multiply by the power, what is the power that's on it in the first place?
-1, so negative. And then, positive, and then 2 over x to the third.
Yeah. Okay. Did we have 28 to do? Did you guys do that one? Yeah? Okay, how do we do that one? Find the derivative, okay. Explain the first step to finding that derivative. Yep. Okay. Is it asking me to find all of the slopes that have a value, or am I being asked to find the slope at a specific coordinate? Slope at a specific coordinate. So honestly, what I did on this equation, I did the math, I simplified everything and cleaned it up and got an equation and then plugged in from there. But let's cut to the chase. What is the x value that I want to solve for?
1.
1. So this notation says, take my derivative that I didn't clean up yet and plug in 1 for x. So Kyle, plugging in 1 for this, just that front part of the numerator, what do I get?
4, or 8,
1 squared plus 1 is 2, 2 times 4 is 8. Adrian, plugging in 1 for this second piece of the numerator, so it's minus whatever we get from that. What do we get? 8. Okay, right here, it'd be like 8 minus 8, 0. Be careful, we gotta make sure that the denominator is not also 0. Matthias plugging in 1 for x in the denominator, what do I get?
4.
1 squared plus 1 is 2, squared is 4. Okay, so then Franco, what is the tangent line through this coordinate that has that slope of 0? Slope of 0 is a line like this. Julia, what is it? What is the slope, or what is the tangent line that goes through this coordinate that has a slope of 0?
Y minus 2. No,
Okay, y minus the y value equals slope times x minus the x value, commonly known as y equals 2. Can I just sort it? Goodness me. All right, I was kind of expecting you guys to actually have questions. You didn't ask a thing. All right. I do want you guys to do a little bit of homework on your own, which is to look a little bit at 3.4. Those of you in physics, what's the derivative of position? Velocity. Because derivative is how is your position changing over time? Well, change in feet per second, oh, that's velocity. Then how does your velocity change if you are speeding up, if you are, there's acceleration. Okay, so just look at it to see what those things are, because 3.4 that we will start with tomorrow is kind of applications of derivatives in the physical sense that you understand velocity. Can you have negative velocity? What does that mean? You're going the other direction. Okay, the other direction, is that up or is that down? If it's vertical motion. Negative velocity is down. And I right or left, which one is negative velocity? Left, okay. I was yelled at one year because someone was like, I didn't know that. What? And if I have an object that I throw up in the air, what is the velocity right when it's turning around? 0. So it's not moving at all, right? Then positive velocity going up, negative velocity going down. What is its speed going up and speed going down? Like, is it also positive then negative? It's always positive. When you're the little bug on that rock that's screaming towards the ground, you are the center of the world and your world. And you're like, oh my God, the ground is coming really fast. I'm going super speedy fast. People from 6th period, maybe it was here. When are you speeding up and when are you slowing down? Looking at velocity and acceleration. First of all, just a thrown object. What made it turn around? Gravity. Because the body at rest and stay at rest, body in motion and stay in motion. What made it turn around was gravity. The only acceleration that's on it. anyway, that's all.